Hello, and welcome back to the Carbon Capture Magazine podcast. I'm your host, Danielle Piekarski, and today I am joined by Ben Cannell, Innovations Director at Aquaterra Energy. Thank you for joining me on the podcast today, Ben. We're excited to have you here.
Thanks very much.
Of course. So let's start things off by having you tell us about yourself and Aquaterra Energy as a company.
Okay. I've had various different roles within my career in the oil and gas industry, having started with Schlumberger Electric Line over 20 years ago. And I've been project engineer and various other different roles within Aquaterra Energy. And finally finishing with my current role, which is the Innovations Director, which has over the last few years especially had a strong focus on energy transition innovations as the company develops into a more diverse energy service company.
Thank you. And one of Aquaterra Energy's focus is offshore CCS, or carbon capture and storage. Can you dive into what offshore CCS is and how it is different from onshore CCS?
Yeah, I'll be happy to. So a lot of the products and services that Aquaterra Energy provide are predominantly focused on shallower water coastal type areas, and they are targeted as alternative ways of doing things with the focus on reducing costs. What we see with the CCS business is at its core a waste disposal business, so cost is extremely important. So we saw a few years ago that Aquaterra's portfolio of products and services could help quite well with the offshore industry's carbon capture and storage needs, and fitting in quite well there with the cost reduction ethos. Having then looked at how our current sort of suite of products and services can help, such as drilling subsea wells from a jackup in shallow water, reducing the cost and the need for a semi-submersible, getting under the lid of these types of projects, it quickly became apparent that there were some unique issues that the carbon capture and storage world faced over and above what traditional oil and gas projects had. And that's where we then became into developing and innovating new ideas. And these are all focused on offshore CCS projects for a very good reason. What we see is that the public generally don't want to see large industrial developments near to where people live. And some of these storage sites for CCS, whilst billed as being legacy oil and gas fields, typically aimed at aquifers, and offshore they are saline aquifers. So onshore they could potentially interfere with groundwater. So moving these sites away from population areas where people don't live makes a lot of sense. Putting them in areas where they don't affect groundwater supplies or other things like that is important, but they need to crucially be close to industrial clusters where there are significant generators of CO2 pollution into the atmosphere. And the shallow water coastal locations in many parts of the world, including North America and the UK, are absolutely ideally situated to address those issues.
So is it more difficult to find offshore reservoirs for CO2 storage than it is onshore?
So in many parts of the world, which I just mentioned there, North America, the UK, offshore locations as well as land locations have had extensive exploration work, seismic work completed. And there's a very good understanding of the subsurface storage sites and how their performance might be, with lots of readily available data. So from some respects, there's no real difference in selecting an onshore or offshore storage site from a point of view of, is there any challenges with putting that in place? Clearly, the costs of the infrastructure to put an offshore site in situ is greater than that of an onshore site. But as I mentioned before, the challenges, especially in the UK where we've got a higher population density with respect to landmass, it's those challenges of putting a drilling unit in a farmer's field, which might be close to a village or a town centre. It's much easier to address those issues if that's pushed offshore, several kilometres offshore, where the public generally aren't affected by what's going on.
Right. Okay. So how do you go about monitoring the injection site?
That is an extremely important part of the integrity of the CCS storage sites. It's also extremely important for the early and first sites to be put in place where the public, regulatory bodies, the industry in general are going to want to know how the storage is going, what sort of injection rates are achievable. So there's a lot of economic reasons why you'd want to do monitoring in the first instance, as well as a lot of reassurance to prove out that this is a safe way of doing things. So looking at that, we often hear, and it's often touted about water column sensors and things like this, where they detect CO2 in the water column or on land and set off an alarm. Now, our view as an organisation is that is a very reactive way of performing monitoring, in much the same way as a fire alarm is reactive. An alarm goes off, you leave the building. There's not really much else you can do about that. And in our view, if CO2 has entered the water column, something really seriously has gone wrong with that site. We like to have a focus on proactive monitoring, and we believe that is where the industry will have a high degree of focus in the coming years. So from that, it's similar to what happens in the oil and gas industry at the moment with looking at a formation and applying calculations about how that might drain down the hydrocarbons. And for the CCS injection, it will be more about plotting out how the CO2 plume will migrate through the formation of the saline aquifer or whatever it might be that you're injecting it into, areas where you don't want it to be, effectively planning it. And then once you've done that plan, if you can have an effective subsurface monitoring campaign that uses maybe passive and active seismic nodes to act as weather bells, if you like, to tell you that the injection plan is going to plan, or maybe it's ending up in an area where you didn't want it to go, such as an area where there might be a legacy well or a geological fault line. Before we get to a point where CO2 enters the water column, then we can cease that injection and we can get the problem addressed. And we feel that is a much better route to take than just purely a reactive approach to monitoring.
So can you tell us more about Aquaterra's platforms for CO2 injection, for example, the C-Swift platform?
Yeah, there's a range of our legacy oil and gas products and services that, as I mentioned earlier, are very well suited to CCS operations. And in fact, we're providing engineering and feed work and quotations into many CO2 storage sites right now. And they range from where a storage site is looking to have subsea injection wells to supplying our conversion package for jackup rigs to complete that subsea work, which is our subsea drilling riser, through to our C-Swift platforms that are a low-cost, quick-to-install platform that can be installed in many parts of the world via a jackup, that lower cost, lower the amount of steel and therefore the amount of CO2 that a project generates, and can be a very good option where a particular project wants to use dry trees rather than wet trees for the injection process. Further to that, we've expanded out our product range to some of the unique challenges that the offshore CCS marketplace has. That's namely where existing infrastructure is getting used. For example, platforms as a base for the injection wells, platform simplification. So again, coming back to this is a waste disposal business. Cost is king, keep the costs down. It might be necessary for platform life extension to take place, platform simplification. So stripping out equipment and services that are no longer needed or have costly ongoing maintenance or servicing requirements. So that's an area that we get involved in, as well as providing subsurface and water column CO2 monitoring systems and baseline services to look at a site to capture a baseline before the actual injection process begins. So you've got a grounding there. I touched on legacy wells as well as a very unique issue that a lot of these CCS storage sites face. And this is probably a subject for another podcast, maybe another day, because the detail can go on quite a lot. But coming back to where I started, which is a lot of these coastal storage sites are very well documented from a geological point of view and a formation point of view, which is great because it means it's a low cost way of assessing these areas. But unfortunately, that also means that there's almost certainly going to be legacy wells that penetrate saline aquifers and oil and gas formations that may have not been abandoned in a format that is suitable for CO2 injection. What does that mean? It means that you might need to dismiss a particular storage site because of these legacy wells, because it just is not economically viable, or reduce the economics down greatly to what you could see from that site because maybe you cannot get to a point where you can fill the storage site up completely, or you can only stay at hydrostatic pressure because you're so concerned about the leak path that's created from the legacy well. So that's kind of the issue that's there. And we've been working over the last 3 years to address that, because one of the only mechanisms that's available to address it is to drill what we'd call an intersection well, which is extremely costly and in some cases won't even be technically viable for some of these situations. And this is a service that we've been developing on some of the Track 1 and Track 2 CCS storage sites in the UK, which is vertical well re-abandonment. So this is re-entering wells that have previously been abandoned, that have never been designed to be re-entered again. In fact, they've been severed explosively or mechanically below the mudline, and we're going in and re-entering those wells with a special system and framework to allow us to then correctly abandon them in a low-cost manner for purpose of CO2 storage in the future.
Thank you, Ben. That was really interesting. Do you have anything else that you would like to add before we close things out today?
I guess I would. I think what I'd like to add is that whilst CO2 capture and storage is becoming more recognised as a technology that can be used, there is still opponents to it out there who want to see less use of hydrocarbons or more electrification and renewables going into the system. But we should remember that the Paris Accord and many scientific bodies recognise that in order to stay within the 1.52 degrees of pre-industrial temperatures, it states that CO2 capture will play a role. There's some very hard to abate areas of industry, such as cement manufacture, that its very process generates huge quantities of CO2, somewhere in the order of about 1.8 tonnes to 2 tonnes for every tonne of cement that you produce. And there's a similar story for the steel industry. And there's other areas as well, but there's no real alternative. And unfortunately, we've reached such high elevated CO2 levels within the atmosphere that we've got to, and there's no viable alternatives to some of these things at the moment, that we've got to figure out ways that we can stop those emissions through these industrial clusters, as I mentioned, where we can capture it in steel mills and cement factories and immediately start sequestering it underground. And this is going to be a stepping stone to getting us, hopefully, to keep the planet's temperature within this area that's considered the least damaging. Otherwise, we're going to be in real problems.
Absolutely. Again, we are talking to Ben Cannell, Innovations Director at Aquaterra Energy today. Thank you again, Ben, for your insights and knowledge. We really appreciate it.
No worries.
And thank you to our listeners. If you or your company is interested in joining us on the podcast, feel free to send a message to Carbon Capture Magazine. Until next time.